Hi and welcome back. In this video we'll learn how to make a character in Scratch move more smoothly on the screen. We will also talk about general principles of animation used in computer games. Let's get started. Let's create a new program in Scratch. You can use the one we created last time if you saved it, but I recommend creating a new one to refresh in your memory what we did last time. Now go ahead and delete the default cat character. Add a new one and place it in the bottom left corner of the screen. If you don't remember how to do that, I recommend that you pause the video and check the previous one. Let's now add some code to make our character move to the bottom right corner of the screen and then turn around. Again, if you don't remember how to do that, please refer to the previous video. Finally, let's make the program run when we press the green flag button. And now when we click the green flag button, the character moves to the other corner and turns around. Before we make our character move more smoothly, let's talk about the move and turn blocks in a bit more detail. Even though the name of the move block suggests that the computer moves our character, this is not really the case. What the computer does is it erases the sprite of a character at its current position and draws it again at the new position. This is why it looks as if the character teleports to the other side of the screen. The same applies to the turn block. Instead of actually turning the character, the computer erases the sprite of a character at its current position and redraws it at the same position but facing a different direction. Because of this, there are two things we need to do to make our character movement smoother. First, instead of moving our character 400 steps, we need to split the distance into smaller ones. Let's now replace the move block with 5 move blocks and set the distance for each of them to 80. In other words, instead of moving our character 400 steps at once, we will have the computer move it 80 steps 5 times, which in total will result in the same 400 steps. Let's add a new move block and set the distance to 80, like this. Now we need to add 4 more blocks like this one. To duplicate a block, you can right-click on it and choose Duplicate. If we click this group of 5 move blocks that we just added, our character will still teleport to the other side of the screen just like it does when we move it 400 steps all at once. So the other thing we need to do to make our character move more smoothly is we need to add a pause after each move block. Let's do that now and I will explain why we need a pause a bit later. To add a pause, we need to scroll the blocks list to the orange blocks. The block we need is the very first one in the orange section, the wait block. Let's add it after each of the move blocks, like this. Now, if we click this move wait group of blocks, our character will in fact move in smaller steps towards the other side of the screen. So why do we need to split the movement into smaller parts and have the computer wait after each of the parts? The basic principle of animation and motion picture in general is that if you have 2 images of the same object, and the positions of the object in the images are slightly different, and if you quickly alternate between the images, it will look as if the object is moving. The faster you alternate between the images, the faster the objects in those images will appear to be moving. The code we made earlier effectively creates 5 different images, and in all of the images, the position of the character is different. However, if you change the images too quickly, it will look as if the object in the images teleports, instead of gradually moving from one place to the other. This is what was happening before we added the wait block after each of the move blocks. Because modern computers are very fast, the natural pause between the images is too short. This is why we needed a wait block after each of the move blocks. Now because we have split the movement into 5 separate images and added a pause after each of the image, our character moves in a more natural fashion, but the movement is still a bit jerky. How do we make it smoother? To answer this question, we need to become familiar with another principle of animation, frame rate, expressed in frames per second or FPS. Every image in an animated series of images is called a frame, and frame rate is the number of frames or images that get shown in 1 second. For an animated series of images to look smooth, the frame rate should be high enough. Normally 30 FPS is just fine for a motion to appear smooth. Now it's math time. If you want to display 30 frames per second, the pause between 2 frames must be 1 over 30, which is approximately 0.033 seconds. If we now change the pause in our code to 0.033 seconds, our character will move more smoothly. Yay! Now there is another issue. Even though our character now moves in a more natural fashion, it moves rather too fast. How do we slow it down? There are two ways to slow down the motion. One, to increase the pause between frames, effectively decreasing the frame rate, which isn't something we would want to do. Or two, we can increase the number of frames the motion takes. To do this, we need to split the motion into more move blocks, say 10, but it would be annoying to do that by duplicating the code blocks. Is there another way to have the computer repeat the same set of instructions multiple times? If you said we can use a loop, you are absolutely right. If you don't know what a loop is, I recommend that you refer to the previous video series. The loop block in Scratch is also in the orange section. What we need is the repeat block. Let's drag it to the code area. Whatever you want Scratch to repeat must go inside the repeat block. In our case, we need to repeat the move and the wait blocks. Let's detach the last move and wait blocks from the group of blocks we added earlier and move them inside the repeat block. If we now move our character back to the bottom left corner and click the repeat block, our character will move to the other side and off the screen. This happened because we just had it move 80 steps 10 times, which totals in 800 steps instead of 400 steps that the character needs to move to reach the other edge. To fix this, we need to set the distance in the move block to, 40. And now our character moves slower. You can go ahead and play with the numbers to find the combination you like the most. Now let's make our character turn around smoothly when it gets to the other side of the screen. To do so, instead of having our character turn 180 degrees at once the way we did it last time, we need to split the rotation into several frames the way we did it with movement. Go ahead and try doing it on your own. Alright, so we need another repeat block here. Inside the repeat block, we need a turn block and a wait block. I'm going to keep the number of repeats at 10, so I need to set the turn to 18 degrees and the pause to 0.033 seconds. And now our character moves and turns more naturally. Finally, let's add a when green flag clicked block to the code we just made, and delete everything else. Cool. Let's now save this program to be able to use it next time. If you are signed in, your program is being saved automatically. If you're not, or you don't have an account with Scratch, you can save your program to your computer. To do so, go to File, Save to your computer. In this video, we'll learn that to create an illusion of smooth motion, we need to have the computer show a bunch of images, also known as frames, at a certain frame rate expressed in frames per second, or FPS. One way of doing that in Scratch is by using a loop. There's one more thing I'd like to mention before we wrap up this video. Some of you might have realized that the blocks we use in Scratch are somewhat similar to functions we used in C in the previous video series. For example, if Scratch was a text-based language like C, instead of adding a move block, we would have probably had to write something like move 30. Looks pretty similar to, say, printf hello, doesn't it? I wanted to mention this to reiterate that even though Scratch is visually different from C, it essentially does the same thing. This is it for this video. In the next one, we'll fix a few issues that we have in the program we made this time. We will also continue learning how to make our character move around in a more complex manner. See you then. Bye.